To finish off this section on transistors, I'm going to briefly review some other transistor circuits that you'll come across in books. At the moment, the idea is that you'll recognize them and have a concept of how they work. However, we'll return to them in later videos for a more detailed discussion. I'm going to start with a transistor as a switch. In this role, it's an important part of power and digital electronics. But since these videos are about small signal analog circuits, I'm going to be quite brief about this function. Before going on to it, it would be useful to review video 66, which introduces this function of a transistor. The transistor acts as a switch when the base collector diode switches on. To ensure this happens, a large enough signal needs to be applied to the base. It's important, however, to ensure that the ratings of a transistor are not exceeded. Let's start with the base. Since IC is equal to beta IB, enough base current must be supplied to turn the transistor completely on, causing the collector voltage to fall below the base voltage. The easiest way to arrange for this is for a base current which is in excess of what's required, but must be less than the maximum rated value of a transistor. This base current can be set by a resistor, as shown in the diagram on the screen. Let's take the BC337 NPN transistor as an example. The maximum base emitter voltage is 5 volts, so we must make sure that we don't exceed that. The minimum value of beta is given as 60, and the maximum current IC is 800 milliamps. If we were going to use the whole current and switch it on in the worst case scenario, we would need 800 divided by 60 is equal to 13 milliamps into the base. This would make RB equal to 4.3 divided by 13 milliamps, which is 330 ohms. But the transistor is a current source, and surely we wouldn't run it at its full rating anyway. Well, the collector current will be limited by the load as shown on the screen in the diagram. And when a transistor is switched on like this, it is operating in a different mode with both its base emitter and base collector diodes on, as discussed in video 66. If it's a motor you're driving, then the maximum current will be the stall current of the motor. That is the current drawn when the rotor is held still. If it's a relay, then the resistance of the coil will limit the current. Otherwise, you can add a current limiting resistor to control the current and set it to an acceptable value, making sure, of course, that there's enough flowing to turn on the device that you're trying to control, as shown on the screen. If it's an inductive load you're driving, like a relay or a motor, you need to put in a protection diode as shown in the diagram on the screen. This is because an inductive load can supply a large voltage when it's turned off and its magnetic field collapses. Driving large loads like a big motor can be problematic because large transistors have a low value of beta, which means large base currents, and these may be difficult to supply. In this case, we can use a pair of transistors, a small one driving a large one as shown in the diagram on the screen. This connection type is called a Darlington pair, and we'll discuss it more in the next video.